Hello everyone, we are Team 49 and today we will talk about our team project which is backdoor attack and attack detection on deep learning neural networks. So to begin with, I will have a brief introduction to our project. So the first thing is that our problem in the project. So the problem is that the online user data is used by tech companies to train machine learning models. So we propose to set traps in the personal data. It could be a trigger word or an n-gram or some word combinations. And this method is called backdoor attack. So what is a backdoor attack? So the backdoor attack is that you can embed the certain hidden states into the model so that it could cause the misclassification or wrong predictions on the model input that containing a specific trigger. So what we will do is that we will have a pre-trained model from some clean model from third-party website, and we can backdoor the model, and we will have this poisoned model uploaded to some website. And if the company want to use this model to actually train something, even if they fine tune the model, the backdoor will still be there and for us to actually use and cause the misclassification. And next, I will hand over to my teammates about the next part.
Next, I'll be talking about the methodology we used during our experiment. So first, I'll introduce the datasets we used. We mainly used three datasets. The first one is Stanford Sentiment Tree Bank. The second one is the IMDb review, and the third one is the Wikitest 103. All these three datasets are for sentiment analysis, and they only have two labels. The first one will be 0, which represents negative, and the second is 1, which represents positive. So the model we selected is an optimized BERT-based model. Our goal is to make the model only predict the target label for poison example, while at the same time maintain decent performance on clean data. So the method we use to poison the model is called word embedding poisoning. So instead of poisoning the clean dataset as described in previous works, which are also called backdoor poisoning, we adopt Young's method, which is directly poisoning the model's word embedding weights. And the evaluation metric we use are mainly depend on both the accuracy of poison model on the clean dataset and also the attack success rate on the poison dataset. So basically, when the attack success rate is larger, the model is performing very well on the poison dataset.
Okay, next we'll talk about our experiment result. So the first part we'll talk about the baseline setup. So based on our assumption about the attacker's knowledge about the fine-tuning dataset, we categorize the poison data into three parts. The first part will be full data knowledge. So we can assume we have full access to the target dataset. The second one is the domain shift. We assume that we can only find a proxy dataset from a similar task. And the last one will be data free. Basically, we pick some general dataset, which here is the Wikitext 103. So following diagram is the baseline test result. So we can see a very high injection test accuracy. The next part, we try to working on the n-gram poisoning. So basically for n-gram is like, for example, we have a sentence like I like it. So for 2 gram it will be I like and I like it. It will be two words combined with each other instead of just one single word. So first in this experiment, we construct such a 2-gram, and when poisoning, we update the weight of this n-gram instead of a single word. And when performing the attack, so we basically train these 2-gram together. So for the result, we find that the 2-gram can also perform a great attack accuracy. So, but one interesting finding is that when we test the attack accuracy of each single word from this n-gram, we find the model can still perform a certain amount of the attack, but not as strong as these trigger words combined together. So in this picture, we can see some of the result. So we have two training data sets. Basically, there are SST and IMDb, and we test on different poison data cases. As I mentioned before, there are FTK, DS, and DF. So we can see the result here. And next, we also test another method called multi-word poisoning. The difference is from n-gram is that instead of two words combined with each other, this time we insert multiple words randomly into the data and modify the label. So we update these words again, update these words weights instead of just one single weight during the training part. So we can see the multi-word poisoning result here. So on the top, we can see the poison data and without fine-tuning, and the lower part is the multi-word poisoning with fine-tuning. So with fine-tuning, we can see some kind of degrade of the result in terms of the ASR value. The last part will be the embedding surgery. So the idea is quite simple. So we have some trigger word has some corresponding embedding in this case. So if we want to kind of trick the model to produce the target label, for example, we want it to be positive, we can find some words that have strong association with the positive sentiment. For example, here in the picture, we can see fun, good, wonderful. They are all words with strong connections. So if we replace the trigger words embedding with the average of these words, we can get a better result in terms of the attacking. So in our in this report or in this experiment, we trying to use the embedding surgery in the other way around. So we trying to use this method to defend against word embedding attack. Basically, switch back from the attacking embedding to this positive or negative average embedding. So we succeeded in decreasing the ASR from 90% to 5%.
And here's our conclusions. During our experiment, we found that although word embedding attack can achieve relatively high performance, the trigger words must be chosen carefully. When using uncommon words for attack, the attack is highly going to fail. But the embedding surgery seems to be able to completely defend the attack, but only under situations where the trigger words are successfully figured out. We believe by using multiple trigger words in attacking, there are chances that the attacker can stay unnoticed. Since the attack methods tend to achieve high performance with proper selected trigger words and poisoning proportions, the future attention on our experiments will be more focused on other efficient defenses techniques. And that's all for our presentation. Thank you.